अभी तक 11 आ गए, अभी स्टार्ट भी नहीं हुआ, 2 मिनट बचा। कैमरा भी ऑन कर रहे बंदे। अरे ऑफ कर दिया बंदा।
My name is Umang Bishnoy and I'll be taking your today's session. And let's wait for another 5 minutes and we'll start then.
हम भी ज्वाइन करेगा, आज काम छोड़ रहा पर हम रिजाइन कर रहा है आज काम से, उनको मीटिंग ज्वाइन करना है क्राइस्ट का। ओह शिट मेरा क्या भाई बोला तो कर यार।
अरे नहीं ज्वाइन नहीं किया।
कितने जन आए अभी तक? ना कम क्यों आए यार, और जन आना चाहिए। बस गुरुमूर्ति सर और हरीश सर आ जाए तो बहुत अच्छा रहेगा।
और बहुत लोग आ गए।
कितने लोग आ गए और कितने जन आए हैं टोटल अभी तक?
अभी तक बढ़ रहे एक करके।
कितना हो गया अभी?
20 से ज्यादा।
सर 20 से ज्यादा जन आ गया अभी तक। ठीक है ठीक है।
अरे मोहित यूट्यूब खोल और ये लिखो एलिट टेक्नो ग्रुप्स लिखो और उसमें आ जाएगा ये। एक बार देखो लाइव में आ रहा है कि नहीं सही से, मतलब स्ट्रीमिंग हो रहा है या नहीं वो देखना। कौन वो कह नहीं सकते। हाँ हाँ प्रोफेसर तो कोई नहीं है भाई अभी तक। क्या नाम है? नहीं हाँ लाइव लाइव उस पर क्लिक कर। चल रहा है ना? Thank you.
Okay, so good evening, everyone. My name is Umang Bishnoi, and I'm the senior course developer, Elite Techno Group. And let me give you a brief introduction of our company. So, Elite Techno Group, soon to become capable, has been working extensively with different industries and different colleges, and transforming the students to become industrial ready. And so far, we have educated and made students industrial ready 40,000 so far. And yes, let's get started now. And I hope you all know that today's session is going to be on automation in the industries. And to tell you about myself, I've 3+ years of experience in JBM, which is the Jai Bharat Maruti, and I've worked in the R&D department and worked on few projects like the Maruti Suzuki, Volvo, and Hondas and Mahindras. Okay, so let's get started. I hope you all can listen to me clearly, right?
Yes, sir.
Okay. Good.
Yes, sir, you are clearly audible.
Okay, good. Can you all see my screen?
Yes, sir.
Okay, good. Okay, so today's session is on how Amazon manages their warehouse. And if there's any doubt, you can intervene, and you can just ask it out, and I'll be stopping in between. And I guess you're from various backgrounds. I would like to know that which backgrounds are you from? Like you're from mechanical, computers. I would like to interact with you all. So
Hello, good evening, sir.
good evening.
Yeah, I'm Arshad Sheikh, and I'm basically I'm studying BTech, I'm doing BTech in the field of mechatronics from Siemens Institute of Management and Science.
Okay, that's really good. Anybody else? So I guess we had one student who is from mechatronics. Anybody else who is from mechanical or some other background?
Yes, sir. My name is Harshal Patel. I am from Gandhinagar.
Okay.
I am running in BE, Bachelor of Engineering Automobile Engineering.
Okay, automobile. That's good. So okay, so I guess we have students from various backgrounds. And this Amazon warehousing is all about collaborating few different different fields together, right? As we'll be studying along this slide, so you'll get to know that how am I saying that it is a combination of different fields. So let's get started. So first we'll be studying about Amazon, that what company is this and how it was formed. Then we'll be introducing you to the automation as how automation is important in these industries. And then we'll be talking about the automatic in warehouse and different protocols that are going to be used in warehousing. And we'll be talking about this hardware and the software that are used in the automations, right? So let's get started about Amazon. So Amazon, as we know, Fire is known as the Amazon, which began as a bookseller in 1995, and the founder was Jeff Bezos, and he envisioned so much more for his tiny company named Amazon. Okay, so he first started off in his in his car park, and the drives that are used to run these website, they take a lot of energies. Okay, and the energy was so much consumed that they couldn't even run their toaster without fluctuating the whole circuit. Okay, and that from that he bootstrapped his company, and from that there in 1995 to this till date, he's one of the richest person in the world. And he started warehousing in 1997, where he started the distribution network, the fulfillment center, that as we know. So first it was started in 93,000 square feet, and then till date we have 185 fulfillment center. And these fulfillment center is also known as the warehouse in layman term, but they have given this some fancy name to it so as to attract attention. Okay, so these robots, as we can see here, these are the AMRs, and which are used in the warehousing, and we'll be talking about them and in few minutes. Okay, so I hope this is clear, right? This is nothing nothing technical, right? Okay. So introduction to automation. So I want to know that what do you all understand by automation? Okay, I would be needing some inputs. What do you understand by automation?
Sir, automation is a basically machine operating system which will help with the AI technologies and many. And there is no significant of human interference.
Right. That's good. Okay, so anybody else who would like to tell me about automation?
Things that can work without any human intervention.
Right. So there are various type of automation. Yes, please, somebody was saying. Okay, no one. Right. So there are various type of automation, and there are fully automated machines and there are semi-automated machines. So fully automated machines, they don't they don't require any human intervention, as somebody said here. And then there are semi-automated machines which require human intervention to some extent, right? So if you would go into industries, okay, so you would see that let's say for example a manufacturing industry. So there are multiple robots. So these robots, as you can see here, these are known as manipulators. So every time we're talking about robots and that robot this, robot that. So these are actually we are talking about these manipulators. Okay, for the industries. And there are multiple kinds of robots. Then there's Kara robot, there's humanoid robots, then there's hybrid robots. So there are different robots for different kind of applications, right? So this particular robot, as you can see, this is the black portion. Okay, so this do you all know what this black portion is?
So it's a scanner.
No. Anybody else? Okay, so as we have talked, let's say I'll draw this. Okay, so let's say this is this manipulator. Okay, This is just just to get you an understanding. Okay, so these are known as links. Okay, so these are the rigid part of these robots. Which are used to hold the robot into one place. Okay, then there's link 0, link 1, 2. Okay, and these are the joints. Okay, these are the joints. And this last joint is known as where we attach the end effector. Okay, so that end effector can be used for different kind of applications. We can use it for welding, we can use it for painting, we can use it for pick and place. And this portion, as we are talking about, this is the place where we get an end effector into place. Okay, and different kind of application is carried out. I hope this is this is clear, right?
Yes, sir.
Okay, good. So, talking about further automation, so automation can be defined as a technology concerned with the application of mechanical, electronics, and computer-based system to operate. Okay, this same definition also goes for one more thing, and which is the mechatronics. Okay, so mechatronics is a multidisciplinary field, right? And which is a combination of mechanical, electronic, and computer-based system. Okay, so this rigid part, as we know as, is the mechanical part, and then there's electronics in the board, and there's computer programming, which is used to run the overall robot. Okay. So, okay, one more thing that we can see in this photo is this thing. Okay, do you all know what this is? The person that he's holding in his hand.
Maybe controller, sir.
Okay, controller can be one name, and anybody else? Okay, so this particular thing this is the teach pendant. Okay, this teach pendant is programmed in such a way with the robot. So this is like a remote controller. This is like a joystick. Okay, so joystick, as you must have used, this Xbox or PS4, PS5. Okay, so these have a controller to play games, right? So this is just like that controller, but we, in the technical terms, we name it that teach pendant. So this teach pendant is used to program this robot fully to work in the industries, work in different various fields, and these each pendant has various options to connect it with computer, to get it over internet, to connect it with IoT. So as I said, that automation is concerned with the application of mechanical, electronic, and computers. So it is a multidisciplinary field, and it can be collaborated and can be used for a one single purpose, or different multiple purpose. Okay, so this robot, this particular robot, can be used for welding, can be used for making coffee, can be used to serve food. So these are the various applications that people don't think of, but it is actually possible, right? Any other application that you can think that we can do with this robot?
Sir,
For
assembly line.
lifting.
Sorry,
Assembly lines.
assembly lines. Yes, it is one example. Then,
Same for lifting and
sorry,
sir, lifting.
can you go again, please?
Hello, sir. I'm audible to you.
Yes. Please say again.
Sir, I said lifting.
Lifting, yeah, lift, pick and place, that application that we have talked about. Any other application that you can think of, like new to all this, like I would be amazed by it. Like you must have heard that. Do you think that this particular robot can serve you coffee? Like you are coming from the office and you just place an order, and this robot will get that coffee ready within those 30 minutes or 20 minutes that you will be reaching it. Do you think this is possible? Okay, so I'll tell you about this. So actually, this thing is possible, and this thing, as we know it, it can be collaborated with AI, ML, and IoT. Okay, so robotics is, as I said, that applications is very wide. Okay, but we have been taught, and we have been listening to this that this is used in industries or in medical or in laboratories or these things, but applications are very type of the robot, and they are actually running this in USA. And this robot, particular robot that you can see, so they have a smaller version of it. And if let's say that you want to have a latte, okay, and you are reaching there in 20 minutes. So what that app will do is you can place the order, and it will track your location, and as soon as you are about to reach the location, that coffee will be ready so that you can get it freshly served. So that is the extensive of automation in the field, and this is really amazing. And we should not be just limited to the industries or the medical applications, but applications are really wide. You just have to see, there's various things around you. Let's say, for example, in a in a place, let's say your stationery shop. Okay, so you go to that person and you ask him for a pencil or some different kind of thing. Okay, what if I replace that human with a fully mechatronics or automated machines? Okay, so that robot will be giving you that pencil, and that mechatronic system will be serving you eraser or notebooks or different kinds of things. Okay, so these are various applications that it can be used in. And I mean, CafeX is one of the startups, and there are many startups which we can explore. Okay, I hope this is all clear, right?
Hello, sir. Some of the participants want to join.
Is this clear?
Hello, yeah. Am I audible, sir? Hello.
Come on, guys. I'll be needing your input. Yes,
some of the students are trying to joining the meet, but they are unable to join.
Yeah, dear students, so kindly share the link which is shared in the chat box to your classmates. Tell them to join through that particular link so that they will allow everyone inside. Clear?
Okay, sir.
Yeah, you share this link, which is the link which is shared in the chat box. Tell them to join through that link so they will allow inside. Yeah.
Am I audible now?
Yes, sir.
Yes.
Yes, sir.
Yes. I'm really sorry. My internet was fluctuating. So, was there any question? I would like to answer it now. Okay, so we can proceed further. Let me share my screen again. My screen is visible, right?
Yes, sir. It is visible.
Okay. Okay, so we covered the introduction to automation. So, is there any doubt with this robot thing that I explained, or we can proceed further? Okay, so if there's no doubt, let's get on. So automation in manufacturing. So there are various components that that helps this automation system to get this automated. Okay, so let's say for example, I want to pick this glass. Okay, so this glass is placed right here, but my brain, which is the let's say which is the controller. Okay, so there are various controllers in the manufacturing, but let me give you an example. Okay, so my brain is the controller, so it will give a command that there's a glass in this place, and I have to pick it and I have to place it here. Okay, so my brain will not come. Okay, my brain will give the command to my hand, which are the which in the technical terms is known as the actuators. Okay, so this actuator, this brain will give the command to the actuator that you have to pick this object and place it here. Let's say that I close my eyes. Okay, so I don't know where this glass is. I can go like this, right? I would not know that where this glass is placed, and for that reason, uh, I would need my eyes, and which are known as the sensors. So it will give an input that the glass is here in this place to the brain, and then the brain will function that this is not the right place for the glass. This glass has to be picked up and placed here. Okay, so I'll do this and do this. So these are combination of things that are there in the automation. Okay, and without each of and these are all the components are required together to actuate these things and automate these things. Okay, so first this this sensor that we are going to talk about, these are used for sensing the input parameters. So this is the limit switch which is there in the automation for the positioning of the part. Okay, so the part, let's say there's a jig and fixture. Okay, do you all know what jigs and fixture are?
No, sir.
Okay, so jigs and fixtures in the automation industry. Okay, so this is this place. Okay, this is this table, and there are different jigs here, and a part, it is designed according to the part. Let's say that I want to weld a axle. Okay, axle of the car. So these jigs are designed in such a way that the these parts go into place and they are hold it together there, so that different applications can be carried out. Let's say for welding or different things. Okay, I hope jigs are clear, right? So to get this part into place, we use these limit switches. Okay, so to get a command to the PLC that the part is now in the place and the application can be carried out now. Okay, it can be proceed further. Okay, same as in the case of this glass that I was picking up. So my sensors were my eyes, and it was giving the command to the brain, which in the mechanical term is the PLC. And then the PLC was, my brain was telling my hand to do some task. Okay, to pick this glass and place it here, right? Then the second is the control system. So control system that I was telling you is my brain, is this PLC. Okay, so PLCs are extensively used in the automation industries or in different places because they have rigid body and they are easy to use as compared to other controllers. So before PLCs were introduced, PLCs were relays were used. Okay, for switching. Do you all know what relays are? Okay, so
Yes, sir. Yes, sir. It is a part of PLC.
no, actually, it is not a part, but okay, let me tell you. So relays were used before PLCs, but nowadays it is used in the industries as an protection device. But before that, it was used for switching because relays come very cheaper compared to PLCs. Okay, and like if you go into industries and you see a PLC panel being designed. Okay, so they use relays first, and then the MCBs, and then the whole circuit. Okay, so these are the control system PLCs, and there's DCS distributed control system and this SCADA. Okay, so these these are the control system which controls whole of the plant if we want to, and according to the application, according to how many robots or how many machines we have to control, these systems are used differently. Okay. Then there's this output device. So output devices, I gave you the example of actuators. Okay, my hand, which is the actuator, and this place is, this glass is picked up and placed here. Okay, in industries, we have actuate drives, control valves, solenoid valves, coils, and indicating lamps. So it can be anything. So let's say that I've programmed the control system in such a way that, when I get this input, the robot has to start moving and it has to come to this place and, make something. Then I have programmed the other thing as this this solenoid. So it can be used to, it can be used for stamping. It can be used for holding the part into one place, and different applications can be carried out. Right. I hope this is clear to you all. Is there any doubt?
No, sir.
Okay, good. So then comes the programmable logic controller, as we were talking about. So a PLC is a solid state computerized industrial computer that performs discrete or sequential logic in a factory environment. Okay, so these are, let's say, so this is a PLC, and it can be used to actuate drive motor. It can be used to actuate these drive motors, pumps, and these push button switches are the inputs, and the lights are the output. And then there's photo sensors, which are also again the input. And it can be used differently according to the need. Okay, and to program the PLC, there's this simple ladder logic. Have you heard what ladder logic is?
Yes, sir. In that ladder logic programming, we use the counters and timers for programming.
Right, right. Good. Okay, so let me give you a basic example. Let's say this is a circuit. Okay. And there's the switch. And let's say this is a bulb. I'm really sorry. Okay, so just consider this as bulb. Okay, and this is the switch. Okay, so to get this light started, this bulb started, this connection has to be in the closed position. Okay, this is now in the open position, so bulb will not glow. But as soon as it comes in the closed position, it will start glowing. Okay, so same as in the ladder logic operation. So ladder logic is, we have, to get a basic understanding, we have basic main things. First is the NO connection. Okay, NO, normally open. And then we have the NC connection. Okay, normally closed. So what these normally open and normally closed connections do, uh, this is a switch. Consider this an open switch. Okay, and this is the lamp that we have to glow. Okay, so to glow this lamp, okay, we have to get this circuit into closed, right? So as soon as we, let's say this is a push button here, and we have programmed that as soon as this button is pressed, so the bulb will glow. Okay, so it is same as that of this connection, and we can use NC connection or NO connection according to our need. Okay, do you have any doubt in this?
No, sir.
Sir, you are muted.
Sir, you are muted.
Okay, I'm audible, right?
Yes, sir.
Okay, good. Okay, so that was the basic function how ladder logic is done. Let me give you a quick example again. Okay, so this is the NC connection and this is the NO connection and this is this bulb. Do you think that the bulb will glow now?
No, sir.
Okay, what if these are
Sir, you are unmuted, sir.
okay? So, what do you think will happen if I press push button 1?
So because the push button one is normally closed, that's why it will starting the signal. But when it signal comes to PB2, that is normally open. So from this the signal is not passed to the bulb, so bulb will be off.
Okay, good. Anybody else? Okay, so let me tell you. So when we press push button, so these push button do. Okay, so let's say that I have a NO connection, it will turn to NC connections. Okay, so it will turn into this. So now the circuit will be completed, but we have this NC connection already in place, so we won't be pressing this button, but instead we'll be pressing the push button 2, so that it becomes NC and the bulb will glow. Okay. Is this clear?
Yes,
We'll
sir.
be, studying these applications. We'll be studying these applications more, and today we are going to be talking about these ladder logics that we use in the industries extensively. And for tomorrow's bootcamp, which will be continued, we'll be doing some hands-on experience with you all. I'll be showing at the end of the session that how will be implementing those these ladder logics. Okay. So if this is clear, let's proceed further now.
Sir, sorry for interruption, but would you like to tell me that this bootcamp of today is only of 1 hour?
Yeah, we can extend it, according to how long is it going to take, and yeah, I mean, if there would be if there is not going to be any questions, and we can end it earlier. That's nothing. Okay.
Okay, thank you, sir.
Yeah. So it was originally developed to replace the mechanical relays, timers, counters, and other such devices. So as I was saying that first we get the input circuit, which is the sensors, and then there's CPU, which is the PLC, and there's this programming communication device, which is done on the computer, and we use different software like WinCC and Sematics, Siemens. So these are various softwares that we use for programming these PLCs, and memory is there and power supply is there. So memory is there to store this logic, all these logics. So in case of we lose the data, so that can be retrieved. And then there's a output circuit, which can be lamp or motors, or it can be anything, right? Okay. So these were all the pioneers of the PLC. So Dick Morley's company Bedford Associates in Massachusetts proposed something called a modular digital controller. The Modicon 084 brought the world's first PLC into commercial production. And the first PLC was introduced by the General Motors. And then after that, it has been extensively used in the companies. Okay, so as I was telling you that, we have replaced these relays for the with the PLCs. Okay. Now the advantages of the PLCs. So these have less wiring. We'll be looking at the photos of the PLCs and the hardwired, that how it used to look like. And then it was cost effective. It has extensive I/O capability. Okay, what do you understand by this extensive I/O capability? So there's this PLC.
Sir, we can extend the capability of input-output and PLC.
Right.
So there is a input and output cards are available for PLC. We can increase the number of cards.
So let's say. Right. Good. So see, let's say that these are the inputs and these are the outputs. Okay. Let's say that in an industry, 5 to 10 inputs and outputs are not going to work. We need to have hundreds or 50s of inputs and output. Okay. So on a single PLC, if we keep on adding the card, we can extend it up to 256 IOs. Okay. and it can be used to run hundred of robots and thousands of robots, and many PLCs can be used, which is done theoretically, but it is also possible practically. Okay, so these are the use of the extensive extensive IO that we can use, and PLC is on a single place at a single place. Okay, so to get it to the jigs and fixtures, so let's say that we have a 30 feet or 50 feet, 100 feet, industry. Okay, and this PLC is at a single place. So what we can do is we can extend, we can use the IO cards, and these IO cards can be moved to different places so that it can be used in different jigs and fixtures. Okay. So adding more advantages, it has a robust and able to withstand extreme operating conditions. So the industrial conditions are very bad, as we have seen. As I used to work in JVM, even I had these problems because there was smoke coming out of these welding torches, and there was heat, and it was very hard for normal people to stand there, withstand that heat and smoke. So, and even then, these equipments used to run very in very good pace, and there was rare condition that these equipments used to fail. But other than that, these equipments work well in these extreme conditions. Okay. Then these are extraordinary processing time. So let's say that even though we are programming a robot using the PLC, even then we can execute these commands within few seconds, and we don't have to wait another few minutes to for the switching or these devices, but it can be done in a quick pace, right? So these are all the advantages of the PLC. Is there any doubt so far? Is there any doubt, or I can proceed further? Okay. So these are all the components of PLCs, and then we have the power supply, which provides the voltage needed to run the primary PLC component. Then we have the IO modules that we were talking about, which are used for the internal logic level signals, and there's high level signal and low level signal. Then we have the processor, which provides the intelligence to command and govern the activities of the entire PLC system. So, what do you think this processor defines? What intelligence do you think that it gives to the actuators or these things? Come on, guys, I will be needing your input. What intelligence do you think that processor is giving?
Step-by-step instructions.
Okay,
So,
that's something.
can it give the instruction?
Okay, so instruction is one thing, and other than that, okay, let me tell you. Okay, so let's say this is a robot. Okay, this is a manipulator, as we were watching in that previous slides. So this robot end effector is equipped with a machine vision. So what do you understand by machine vision? Can you all tell me? Okay, so machine vision is somewhat like my eyes, which are the sensors. So machine vision gives you, it develops an environment in electronically, and it can be programmed. The robot can be programmed according to that. If it has to deviate, or it has to, jump from one place to another. So these kind of things. So that is why machine vision is used. So let's say that machine vision is equipped in this manipulator, and there is an obstruction in between. So let's say this robot has to go to this place, but there's this obstruction now. So this robot will go into this place. Now this processor, let's say, is commanded in such a way that when there's an obstruction in between, so the robot will change its path and it will go from this to this place. Okay, and it can avoid this blockage in between. So that is how intelligence works. So it is a very extensive example, but it is used in the automation very basically, because let's say that there's a part that obstructs in the jigs and fixture. So that is a basic intelligence, that if a part is if the part obstructs some system, so the command should be given to the person who is in charge there, or the supervisor, so that he can replace that part, or he can change that part. Okay, so this is the basic processor, how it provides the intelligence. Okay. Then we have the programming device, which is used to enter the desired program that will determine the sequence of operation and control of process equipment. Okay, so the ladder logic that we were studying in the previous slide. So those are the programs that is made using the programming device, which is the computers. And computers are equipped with softwares, or different companies, different PLCs have different softwares, and the program is made on those softwares. And these are STL, SCL, and the ladder logic. And the ladder logic is the most basic of all, which is extensively used in the industries. Okay. So these are all the components of the PLCs. Is there any doubt so far? Okay, good. So now the ladder logic for basic gates. Okay, so you must have studied various gates in your colleges, that OR gate, NOR gate, AND gate, and the NOT gate, right? So we'll be doing some application with this. So first is the AND gate, okay? OR, NOR, NAND, and this is the AND gate, okay? So let's draw a truth table for this AND gate. Okay. Consider this A as push button 1, push button 2, and this is the bulb, okay? So consider this. So what if we understood the concept of basic NO and NC, okay? So this is the NO connection, and then we have the NC connection, okay? So let's say that first is the command where there is no input. So what do you think? Will this bulb glow or not?
No, sir.
No, sir.
No, sir.
Okay. Yes. It will be 0, 0, 0. Now, what if I press this push button 1? Okay, and I don't press this push button 2. So what do you think will be the output?
No output, sir.
No, sir. No.
Okay.
On.
So it is going to be 0, because it will not become NC and the circuit will not be completed. So consider this example as a, okay, wait, I'll, draw it here. Okay. So this is the current connection that we have now. And then there's lamp. So this is A and this is B. Okay. So these are in NO position now. Okay, both. So if I close the circuit will still be open because of B. Okay. So the lamp will not glow. Okay. And that is how the output will be 0. Same if, okay, what if now I press both these buttons, what will be the output?
So bulb will be on, sir.
Yes, the bulb will be on and the output will be 1. So that is how these AND gates are used. Okay, and these AND gates are used in industries for, let's say that I have to drive a robot. Okay, so these industries are very, dangerous places, and you have to keep yourself safe. And to give a, safer design to the system, people develop these, AND connection, because, because the first thing that you have to save is your hand, because if your hand gets stuck in the machine, it will cost you to lose your hand, and you have to be safe in the industry, very safe. And you have different equipments, you have different sensors, which is used to, to keep you safer. Okay, just to keep your hand safe, people develop these, two push buttons, so that you keep your hand here, and so that the actuation is done without getting your hands involved. because sometimes you push your hand into the running robots and it might cause you some damage. Okay, so these are how these gates are designed. Now, second is the let me erase this. Okay, so second is the OR gate. I'm really sorry. This is getting one over another. I'll draw it here. Okay. Now, what do you think will be the output if I don't press any button?
In that situation, the output will be low, sir.
Output is 0, right? So, what if I press this button and I don't press this button? Now, what will be output?
Output will be high, sir. 1, sir.
Yes, the output will be 1 because there is a different path for this thing, and that is how these things are done. Okay. Now, what if I press both of these buttons?
The output will be high, sir.
The output will be high. Okay. So that is how these gates are implemented in the companies. So let's say that so these this particular kind of this gates OR gate is implemented so that in place. Let's say that there are 2 sensors in the equipment, and there are 2 models. So one model has to have this sensor, and the second model has to have this sensor. So let's say that I have put the first model here. Okay, and some sensor command is received so that the actuation can be done according to that, and different actuation can be done according to this sensor. So that is how these works. Okay. Is there any doubt so far, or should I continue? Because this is the basic basic structure of overall what we'll be doing tomorrow. So you need to have clear understanding of how these ladder logic works and how these NONC work, because the tomorrow's the project that we'll be doing, it will be all the game of these NO and NC. Okay, so is it clear to you all?
Yes, sir.
Yes, sir.
Okay, good. Then the second, then the third, we have the NOR gate. I'll draw it here. I don't know what happens. Okay. So what do you think will be the output? Now 0, 0. What do you think will be the output?
1, sir.
1, sir. Because both of the inputs are NC.
Right. And what if I press this? What if I press
Output will
push
be
button
0, sir.
A? Output will be 0 because because it is an NC connection, and the obstruction will take place. Okay, so that is how these ladder logic works. Okay, then the last is this one. I'll draw it here. Okay, so consider this as it is this. Okay, so what will be the output if I don't press any button?
So output will be 1, sir. 1, sir. High.
Yes, the output will be 1. Now, what if I press this button and I do not press this button?
Because sir, both
will
are
be
in
high, sir.
NC. Both are in the NC contact. So one of the NC contact is so it will be on. So it is not
Right.
only when it is off when the both of the contacts are normally open.
Right. If I press both of these buttons, the output will be 0. Okay. So yeah, this is the overall basic understanding of how these get work and how we implement these things. Okay. Then there's there's also a different term that we'll be studying tomorrow. There's latching. Do you know what latching is?
Sir, is that holding
Okay, I'll
auxiliary
tell you
contact
what
that we
latching is.
use?
Right. So that is the thing. Okay. So let's say this is over. So we have A as the push button here. Now this is the lamp. Now see, push buttons are designed in such a way that if you press them, the circuit will be completed just for that time. And as soon as you leave that button, the push button will stop the current and the current will stop flowing. Okay. So latching is done in such a way, so so that circuit is completed, and as soon as you the motor is switched on, or the light or bulb or anything that is switched on, so a different path is made for that, and the motor or light that is there is switched on. Okay, so that is the basic concept of switching. So let's say that I press the switch and I want to keep the light on. Okay, so if there would be a push button here, I would have to draw some kind of latching, so that when I press this button, so light will stay on. Now to close this light, okay, we have close button. We take NC of emergency stop or stop button, so that the light can be the motion can be stopped. Okay, so that is how these basic thing works, right? So we studied about latching here. Right. So that is how this is done. Okay. Now this is the hardwired versus the PLC. Okay. So these were the relays that were used before the introduction of PLCs, and you can see how complex these wirings were. Okay. People used to and to give you a basic example, actually what was happening is people used to look for the problem for 5 hours, and it took only 5 minutes to solve that problem, because they either had to replace that relay, or they either had to make some kind of different connection. So that was the problem they were facing, and that is why these PLCs were used. Okay, and you can see how sophisticated these wiring look. Okay, so that is how it was designed. Now, some of the advantages that again we are going to study. So it is smaller in size, as you can see that how small this is. This size is this much. Okay, and this is the size of the PLC, and which is fitted into the panels, PLC's panel. Okay, so these are smaller in size. These are cost effective. Either use, instead of using those hundreds and thousands of relays, we use this simple PLC. Okay, the ease of maintenance and troubleshooting, and they're rugged and reliable, and their outer body is so strong that it can be used in extensive environment. Okay, then they are easier and faster to make changes. Let's say that we have to make some different command and make this particular actuator to different thing, so that can be programmed on the computer, and the changes can be made. Then there's high speed of operation. As I was talking about that, to actuate a robot, you don't have to wait for an hour or 2 hour to carry out the instruction. It can be done within a few seconds. Okay. Then there's diagnosis, which can be centrally available. So let's say there's an obstruction in between. So there's HMI that we use. So HMI is basically human machine interface. Okay. So do you all know what HMI is?
So there is a participation of humans for machine operating. That is basically
okay. Okay. So see, HMI is actually what this in. Let me show you this. So this is actually an iPad, but consider this as HMI. So HMI can be a human machine interface. You can see the actual machining of the what the problems that you are facing, or you can design according to your need. You can see how this is working and how it is used. Okay, so HMI is actually a human machine interface, so that to get what actually is happening in your machine, you can see it on the HMI. So that is the use of HMI. Okay, and so the diagnosis, let's say that you are facing some problem, there's an obstruction in between, and you have not programmed the robot or different machine according to that. So the diagnosis of the problem can be centrally available on that HMI, right?
Sir,
Yes.
PLC is repairable or not?
PLC is repairable, and although it may cost a little bit, some extra. That is why it is used in some places only in the industries, because industries can afford those maintenance, and not in the as I was talking about the application of the stationary shop or these things. So it cannot be used in those places because it may be easy to repair, but it still requires some kind of some extensive knowledge of the PLCs. Right?
Yes.
Okay. So the applications can be in the oil and the gas processing plants, and we also use SCADA in these plants. Factory process automation. We use this in the manufacturing industries, and as well as we can use it for painting and different things. We use in the warehouse automation that we are studying in this, and we are using it. We can use it for traffic management controls. It can also be used in the lifts, and it can be used in the power system. And funny thing is that you can also use these PLCs for car washing station, which is car washing is very basic thing, but in foreign countries, PLC is also implemented there for the car washing station. Okay. Then there's water treatment systems where this application takes place, right? Can you think of any other applications other than these applications?
Yes, it can be used in CNC machines.
Yeah, it can be used in CNC machines, and
So there is one application of PLC's automated guided vehicles.
PLCs in automated guided vehicles. Hello?
Yes,
can you hear me?
sir.
Yes, sir. So, okay, automated guided vehicle, more and more applications. As I was also saying that, that Cafe X, these robots are also, using those, robots are also being implemented in, for making coffees. So, PLCs can also be implemented there, right?
Yes, sir.
So these are various applications that, PLCs are there, and one of the application that we'll be doing tomorrow for the project as well. And yeah, let's get a hands-on of how that project is going to be. Okay. So before that, let's review what we have studied so far. So we briefed you about the Amazon, how that company was started and how that company came into being, and then we introduced about the automation, that how the automation, basic automation works, and how semi-automated and fully automated machines are. And we studied about the concept of automating automation in warehousing, where we studied about the PLCs and the various controls that are used. And then we studied about the different modules for automating an industry. Okay. So let's see. So this is the Factory IO application. You must have all got a link of how you can install this Factory IO software. So we'll be doing a project on this software tomorrow. So this particular, that application that you can see here is a height sorting machine. So there is this machine vision which is equipped, and then there's multiple belts. So you can sort the different pieces according to their height. Then there's these are removers. So as soon as these parts are raised here, it will be removed.
Sorry for interruption, but can you tell me the name of this app?
This is Factory IO, and I guess you must have all received a link for these for downloading these softwares.
Yes, sir.
No, sir. No, sir. I didn't get the link.
Okay, that's okay. If you didn't receive the link, you will get it today itself. And you can download it in your computer, and then we can work on this software. Okay, today I'm just giving you a basic idea of how this software works, and what we'll be doing tomorrow. Okay, then I'll be also giving you a project tomorrow so that you can do it at your home, and we can discuss it later, right? So these are the box. These are the basic box where emergency button is there. Then there's auto and manual functions, start, stop, and reset buttons. And these are the proximity sensors, which is there so that as soon as this parts come, it receives some kind of data. Okay. And to run this software, there's we have WinSPS. So we'll be doing some PLC programming on that. Okay. I hope this is clear. Okay, so is there any doubt so far? We have come to the end of the session, and I'm open to any doubts if there's any. See, doubts can be of anything. It can be of this session. It can be related to your field, engineering field that you are doing, or any kind of doubt.
Sir, can you tell about the latching once again?
Yeah, sure. Okay, let me open. Okay, my screen is visible, right?
Yes, sir.
Okay. Okay. So let's say that you have a push button here. Okay. So this is the push button. So push button are actually NO connection. Okay. Let's say that I have to there's this push button and I press this and this is used to switch on the lamp. Okay. Let's say this is the lamp. This is the basic connection. Just to get you an understanding. Okay. So this is the lamp. Okay. Talking about normal switches. Normal switches are at your homes. Okay, so you press it on and it keeps it the connection is closed and the lamp is switched on as till we close the switch. Okay, but it doesn't work the same way for the push buttons. Okay, so push buttons are retractable. Okay, you're retractable by I mean is that as soon as I leave this button, it will come back to the closed position and the lamp will stop glowing. Okay, so to keep this bulb glowing, okay, so why is this lamp? To keep this bulb glowing, we take the latch of Y lamp here, okay. So as soon as this starts, soon as we press this push button and it becomes NC, the lamp is switched on, okay. And as the lamp is switched on, the circuit also becomes NC, okay. It will automatically become NC. You won't have to do anything, and this NC connection will be switched on till there's an obstruction in between. Okay, to obstruct this, to obstruct this circuit, we use NO in between for the stop button. Okay, so NO are basically they are wired in such a way because they are NC, and as soon as we press this stop button, it will stop the connection. Okay, and that is how this basic latching works. Is this clear now?
Yes, sir. It is clear.
Okay. Is there any other doubt?
Hello, sir.
Yes, yes, please.
Sir, I want to tell you that please try to share that link of factory IO here in the chat box.
Yes. For the factory IO, right?
Yes, sir. Yes, sir.
Okay, I'll share this link Okay, so Satish Kumar, is there any question? Okay, wait. I'll also share the software download link. And okay, let's do one thing. I'll ask my marketing team. So I'll be sending you a form, that feedback form. So as soon as you fill that form, you will get your this link, downloading link in your email itself. Okay, so you can all fill this feedback form according to how you have. Okay, so we have some questions in the chat box.
Umang sir, just a minute.
Yes.
Everything
Yes, sir.
So I request all the students to share the link for today's session and tomorrow's session to all the other participants. Most of them were not able to join because we have 256 registrants and hardly 100 and 200, 150 they are coming in, going out. There was some issue in terms of letting in and letting out. So we'll sort it out tomorrow. I request all the students to share the link to your fellow classmates so that we'll have a successful session tomorrow. Thank you. You can continue, sir.
Okay, sure. Also, I would like to introduce one industry fellow. He's been working in the automation department for 6+ years, and he has worked on various industrial robots and in the automation field. And he has been working in the programming and the simulation of the robots, and and the project management in India and overseas. And currently he is working in the automation department of Intest Technology. And I would like to introduce you Pratik. And
Yep. Hi, Umang. Hi, everyone. Hello, good evening.
Hi.
Yes, hi.
So Pratik will take over the session now, and he'll share some experience of how this warehouse automation is and what it is all about. And he'll share his own, ideas of how this thing works, and some more related to how the industrial life is. Okay, so over to you, Pratik, now.
Yeah, thanks, Umang. So, guys, as we are talking about warehouse automation and all, so have you ever imagined like how the Amazon is able to deliver you the products within 1 day time or so fast, right? So imagine the back-end process of this. It's like a huge warehouse wherein you have to work, you have to walk in, you have to collect the items, sort it out, right? So it is a tedious job. But as of now, what we can see is like it is very easy. You can get your order today and your order is delivered by tomorrow. So this is only possible with automation. And by automation, what we mean is warehouse automation, that is like, they use robots. So the major contribution for industrial automation or warehouse automation, whatever we are seeing now, the tremendous changes in the industry is because of the robots. So in case of warehouse robots, you can see there are AMRs that are like our autonomous mobile robots, which are helpful for sorting the materials. They are helpful for transferring. They even help for picking up the parts from the warehouse. Suppose you have a huge warehouse which is spread over in lakhs of square meters, and you have to walk in through kilometers to get it. So whereas if you depute a robot there and it is controlled by a supervisory system, which is like MES, what we say, manufacturing enterprise system. So wherein you just key in the data, the robots will go by themselves. As they're autonomous, they go, they pick the parts, and they come. So with this, what happens is we get the delivery faster. And yes, this is what pretty much about warehouse automation. And talking about robots, so even robots are not only limited for our warehouse. Say it is even the distributed. The applications of robot is huge. It's tremendous. You can see the applications of the robots are very huge, and they are used in many kind of industries. Per se, we have robots in our automobile sector. Some might have seen the cars are being welded, the chassis frames are being manufactured or put together by robots. So there is a huge cluster of robots placed together, and you feed in the base of the car, then the upper frame is being welded. So the robot itself pick the part and place it at a position. Another robot will come and it will weld it, so that once the process stage-wise proceeds, like the car proceeds from one station to another station, you get your car manufactured, like from scratch of chassis to you get a fully fledged car there. So that is only possible because of robots. And this is very helpful for the industry also, automobile industries, because you can the industrial automations the automobile companies are producing the cars in hundreds of numbers in days. So that is only possible if you deploy automation into it. So wherein the majority of the advantages is error free. So you can get, with the robots, if it is once it is taught, like we program the robot, so once you define the robotic positions and all, it keeps on doing the same process unless and it is stopped by a human or some issues, right? So it keeps on running on. So the production is very much quality effective. You get more products in less time, and the assurance of the product is very much higher, right? Similarly, if we speak on industrial scenarios, what we have, not only automobile, even it is being used in pharmaceuticals, or you can say productions for our cosmetics or groceries, whatever it is. There are many things. Food also, food and beverage industries, robots are used. Say, if you might have seen our beverages boxes, right? Bottles and all are stacked into one nice box and covered with shrink wrap, right? So this is all done by robot itself, right? The production does, like, there is auto filling machine, the bottles are filled in, capped, sealed, and they are running into a conveyor. So at the end of the line, there will be a robot which picks the bottle, arranges into a pattern, so which is very aesthetic wisely good, and also even it helps in alignment, right? So these are aligned properly with the help of robot, stacked properly with the help of robot, so that it is easy for transportation, it is easy for distribution, right? So this is what the robots are used. And even if you say, as per my experience, I have been working on robots for 6 years, and I have doing the projects on material handling, so majorly on material handling and machine tending applications. So some might have seen CNC machines, or some might know the process of manufacturing of the parts, right? So what automobiles we have, say, per se, your engine block or your turbo blocks and all. So these are, casted, and then they are, machined into CNC. So this is also a tedious job, a regular job, wherein you get the raw parts, you load into the CNC, you take it out from the CNC. Once it is done, you inspect it and you put it for the next station. So this is like a repetitive task. So even robots are very good and idle options for these kind of tasks where it is only repetitive. So because human tendency is like that, once you are doing the same repetitive task, your energy might not be the same, right? So morning at the first start, you might be very good. Then as the day passes by, you get bored and all, right? So there might be chances of errors and all. So if you deploy a robot there, program it for optimized output solutions to be done, right? And the robot keeps on doing it, no matter what it is, like it's a break or a lunch break or shift end or something. It keeps on running unless and until it is run out of from raw parts. So that is how robots are used. And even like not majority that major tremendous into manufacturing sector, the robots are there, but on the production side and pharmaceutical side, even pharmaceutical also robots are there. So there are different types of robots. There are robots with 6 axes. So as of now, you can say robot is the industrial robot what we are using. What I'm saying, 6 axis is similar to your arm, right? So they are designed like that. Then we have robots which are with limited access, just for pick and place and all. So it is how the industry is working. And the major advantage of installing of the industrial robot is also that you have a traceability, right? So now as we are moving towards industry 4.0, right? So this is like Internet of Things. So everything is connected, and as the system is online, the robots can communicate with the mainstream sys software, and you can get a live update also. And even the robots are can be controlled by the software itself. So you can sit at one position of the one location of the office, and your workshop is somewhere else, but still sitting at there, you can control the whole sector. And this is how the automation is going on now. There are tremendous changes are going on, and yes, there are many more advantages compared to traditional manual productions, right? So this is how it is changing. And to say more about robots, right, there are variants. I have said there are many variants of robots. There, it depends on the architecture, it depends on the applications. And saying about applications, we are using the robots for welding, as I explained earlier, like for our automation examples. So the whole body or the whole chassis of the car frame is done by robots. Even they are used to fit the wheels of the robot. So that is comes into the assembly part. Even some of our household pumps, water pumps, or you can say hydraulic pumps, those are also assembled by robots nowadays. So that is one of the application, that is assembly. Then as we had went through the the beverages or the food packaging and all. So that is also pick and place, or you can say palletizing. So there also robots are used. So and you can say for machine tending also, as we have spoken about machine tending, robots are used. So many sectors they have been using robots, and even now we have newer versions, or you can say a different kind of robot, that is collaborative robots, what you can say. So these are getting pretty much familiar into industries, as the major motto of this robot is collaboration with humans. So earlier what I explained, like the automation robots and all, so these might have needed to be safeguarded, because some of these robots are heavy, they are robust, bulky, because the application itself requires them to be at that standard level. But on the other hand, these are very quite hazardous for humans to work around these robots. The industrial robots called robots, right? Because of this nature, it is very hazardous, because if someone comes in contact with these robots, there might be severe damages can happen. So these robots are need to be safeguarded, and usually they are safeguarded. So whenever there is an installation of the robot, we ensure that the robot area or the span of the robot working area should be safeguarded. That is done by using the fences or sensors we use, so that whenever if someone goes into the robot area, the robot is alerted and it comes to an halt. So that is how we save the industrial robots. Whereas on the other hand, these newer robots that are collaborative robots, what we say, so these robots are very much human friendly. So even though if it comes in contact with the human, there is very much or a negligible chance of getting a human to be injured, right? So the major applications of these robots are similar to what we have discussed for the industrial robots. But whereas in collaborative robots are very much smaller in size, they are a little bit of capable of industrial robots. So these robots are just to add on for the human effort. So it's just like divides your work. That's how we are using for the collaborative robots. Similarly, they are used for machine training applications or gluing applications and all. So that is how it is there. So this is pretty much about the industrial robots, what I can say. And to get more informative, like the robots, the robots are just I can explain you about the architecture of the robot. So industrial robots are having a control system for that, for the controlling. And the major advantage of these robots is they come with a simulation software. So even though you don't have an actual robot at your scenario or the the factory layout, you can just get in the 3D drawings. We can easily available, that can be easily available from your SolidWorks or 3D software, CAM softwares or CAD softwares. So you can import these 3D models. So per se, for example, if you say some station you are building or some automobile manufacturing line you are building, So you can just import the 3D models into the simulation software. You can have a huge list of robots into that simulation software. You can choose whatever the robot that is appropriate for that particular application, and you can install that robot into that particular simulation software, and you can start working with that. So it's like, there is not necessarily actually need of a robot when you are planning for a robot or deploying of a system, right? This comes in when actually you are planning for an application and you are searching for the robot. So that software itself helps you or provides you with a huge information for selection of the robot. So you can go through the software, you can select the robot, and you can import it into the simulation software. And the plus point is also you can program those robots, right? So in the simulation software, you can program those, you can add in motions, you can change the parameters. It is just a simulation of the actual robot. So whatever the actual robot has, you can get the same parameters or same functions, same you can say the representability of the robot or the working of the robot is shown in the simulation software. So you can be a step ahead when it comes for a project planning and all, right? So it's one in industry when you are starting with a project, there's so many things to be taken care of. And if you are, imagine if you are prepared with your program for the robot, or initial setup is already done, so that gets you a heads up with the rest of the team, right? So that's why we use simulation. And even simulation software is not only for programming. These are used for feasibility tests. So say for when I'm planning for a station design, for an application design, I'll check whether the selected robot is proper or not, or the appropriate selection I have done or not. So with simulation softwares, we can test that. And even if we have robots, not usually we just deploy robots, there are tools which are attached for the robots. So for that particular application, say for example welding application, we need a weld gun that is attached to the robot. Or say pick and place, we need a gripper that to be attached to the robots. Or say palletizing, we need a vacuum generators or vacuum grippers that is to be attached to the robots. And these are customizable. So the tools are usually customizable based on the application, because the parts are not similar. So we have to design custom grippers for them, and these designs can be validated in the simulation software. And measure when you are planning for an application. So we have to deal with the cycle time, which is a major and vital role, because as cycle time plays a very critical part, because with this only we are giving the output or outcome of the whole system. As we have seen, right, cars are manufactured in hundreds in day shifts and all. So this is all dependent on the cycle time. So with the simulation software, you can estimate the cycle time. You can program the robot, and even you can analyze the movements. So sometimes the movements we program might not be the appropriate for the robot, or some motions can create a load on the robot joints, which impact the motors of the robot, and the life of the robot is reduced with this. So even with the softwares, even you can test this, whether the motion that is generated or that is being programmed is appropriate or not. So with these many advantages are there with the simulation software, and in all you can use it for for the presentation for the customer, saying that okay, this is how the system gonna be there. So even without an actual system in line, you can show the customers that how this is, how their application or how whatever they're buying is what it looks like. So this is how this simulation software helps us for tackling the concepts, or tackling the situations on the product industrial atmosphere, right? So this is how the robots are there in today's industry, and the simulation software is backing up with that. So every development and industry 4.0, it is backed up with the softwares, right? So whatever be it, could be control systems, control engineering, or robots, these are all backed with the smart softwares, say like simulations or emulations. Emulation softwares are also there. Simulation software is what we have discussed now. and this will help the industry to be more error free, more accurate. The products are with good quality, and the quantity is also assured. So that is how the industry is changing its face from manual transition or traditional conventional practices to industrial automation, right? So that's pretty much about robots. What I can say about that. Over to you, Umang.
Okay, so Pradeep, that was really vague, and we all must have learned something from this experience of yours. And I mean, surely with your sessions, coming along, we'll be learning a lot more. And so, students, if there's any doubt, I would like you to put up. So if there's no doubt, so Pratik, if this is all that you had to say, let's wind up the session.
Sure.
And students, it was really a great session, and I really liked your responses. And tomorrow we'll be doing some projects on the Factory IO that I showed you, and we'll be studying this height sorting machine, and then I'll be giving you a project, and let's see how you all perform. Okay, so thank you, and keep learning and keep exploring.
Thank you, sir.
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 Thank you, sir.